So I'll just, okay.
Okay, so
Now you
we're
can
looking at a cavity. You can show inside there, it's got a super long pin, so it's got a very strong external coupling factor. And now we're going to try to find the resonance of the cavity. And what's really, so if I put it all the way in, it's kind of hard to see because it's this big, fat, wide thing. Actually, as I lower it, the coupling quality factor goes down because the mode is extended. And this is kind of cool. Even at this distance of the two halves of the cavity, there's still a resonance. We have this on the paper, by the way. Not quite this far. That only disappears when I get out to here. So the other half of this cavity is acting basically like a reflector that's sort of mirroring back into the other high side of the cavity to make the resonance. And we're looking here in the phase. But actually, if we go, now that we know where we're coupling, we could go back to the magnitude format, log magnitude. And now we can see that peak, right? So as I go over coupled, the peak disappears because it's all in the phase. If I go, as I decrease the coupling, there's another mode up there, by the way. That mode gets low, gets less coupled, and boom, now it's hitting critical coupling where the dip is super deep. In fact, here, I mean, I can rescale it. It's kind of a fake thing because of the log scale, right? But you can see there, and now we're undercoupled. And now it's too far undercoupled. But we can go back to the phase. Oh yeah, we want to go unwrapped phase. And now it becomes a bit more clear, but it's kind of harder to see a step than a peak. Your eye likes peaks. And we've discovered there's another funny option in the network analyzer, which is called group delay. You might ask yourself what group delay is. It turns out it's just a derivative of the phase with respect to frequency. And we can turn that on. And there, now we can see now actually it turns up as a peak. So it's kind of a bit easier to see. So the nice thing about group delay is that it's always kind of visible. Oh, actually it changes sign. Oh, look at that. Of course it changes sign when you go from undercoupled to overcoupled, right?
Yeah.
Let's do an auto scale here. I guess super, right?
Oh, nice.
We need the auto scale there. Okay, you can't do auto scaling on both sides. Well, so this is something we've discovered in recent times. The group delay is kind of a handy way to look at reflection resonances. And you can see there's clearly a higher mode of this box, which is doing the same thing up there, right?
Yeah.
Oh, it's just outside of the. Let's go a little bit higher. I think. What is? Can we go to 15?
You can get to 14.
Okay. There it is. See it up there? There's another mode up there. It's doing the same thing. It's just that when the box is all the way closed, it's less strongly coupled. Look at how far you move this guy out as you get him critically coupled. Boom! It's really like a mirror. It's like I'm reflecting the microwaves as my hand. Yeah. I think that's probably good, right?
Yeah.
For the video? Cool.